All right. Basically, you know how we had that triangle we talked about it last time where outer edge, oh, that did not work that well. And then you had a line that looked like this, when two lines are parallel. We started talking about that last time. And then from there, you pass it back, how's it gonna know? And then you'll need a calculator as well. Basically, we're gonna be dealing with these types of triangles. And perpendicular angle bisector, basically, what's gonna happen, we get a triangle, another one, looks like this, line down the middle, and it's basically gonna bisect here and here. We'll talk about that more later. Okay. Basically, remember with angle bisector, perpendicular bisector, everything gets chopped in half. So basically your sides are the same. So you all bisectors we dealt with at the beginning of the year. And then parallel lines we've dealt with more recently. So that's the gist of today's lesson. And the only other part about this lesson, which is sort of not new, when we solve equations, you might have equations, I'm just going to make one up. 11x minus 5 equals 6x plus 20. I'm just making it up. We're going to be dealing with solving for equations of this type right here. So that's what we're going to be dealing with, basically in and out all period today. And then the only other part with the mid-segment, basically, you have to look at what's your inner and outer line. So this is the inner line, outer line, because there is a relationship between the two. And I will talk to you about it right now. All right. And then you're going to be getting a homework assignment towards the end of the period. We may be able to start it, depending on how well we go through our notes. Now, it's not as long as it looks because of diagrams. But once we get through the notes, from there, we may have an opportunity to start the homework. And your homework is going to be like basically your quiz review. You understand what's going on with this homework assignment, you're going to do very well in a quiz. Quiz is next class. It will be the last quiz grade of the quarter. So, for some of you, you really need to look at what you need to do. Look at your grades. Look at SIS. We're down to our last week. And also, if there's time, we'll talk about what you need to do, especially with some of your Unit 1 or Unit 2 add-on activities. All right. So on we go. Here we go. So the triangle mid-segment, we talked about it a little bit last time. Basically, the inner, outer line, they're parallel. They'll never touch. Okay, also, I know I'm hearing music, it's a little too, I'm hearing it, it's too loud. Number 2, this line right here, the inner, is exactly half the length of the outer. For the outer, is 2 times the inner. All right, so that's basically all you really need to know. So if we look at these first couple problems, now, I told you Don't worry about this 9. Don't worry about the 10. Basically, first you have to figure out, is the 30 an inner or an outer value? Is the, what's that? It's an outer. Now, so this line has to be the inner. So basically what's going to happen is outer equals 2 times the inner. That's what we're going to be dealing with all period. But the good news is, do we have enough information to solve for the x? We do. Because the outer, number 1, the outer is how many, what's the value of the outer? 2. Outer is 30. Inner is x. But what do we have to do to the inner value to get the outer value? Multiply by 2. That's all you're doing. All right, again, that music is too loud. Who's ever playing it, you got to turn that down and turn it off. So yeah, that's all you do. You just follow this rule right here. Boom. I'll put it right here so we see it better. There you go. So your outer is 30. So we follow the outer is 30 equals, well, 2 times the inner. But what's the inner value? What do we designate as the inner value? Right here. What do we designate the inner value as? Look right on the board, ladies and gentlemen. Okay. The inner value is just what? X. So you have 30 equals 2 times x. Can we solve for x at this point? What's the only thing we have to do? That's it. So what's our value of x? Thank you. So 30 divided by 2 equals what number? 15. That's it. So x is 15. Any questions? That's basically the most important part of this whole little activity we're doing for first half of class. The outer edge is 2 times the inner edge. Well, the inner edge is half the outer. Okay, for number 2. What's given to us? Now, don't worry about the 40 and the 70 for now. Don't worry about that. Okay, the 9. Now, is that the inner or the outer? Inner. So the inner value is 9. Do we know what the outer is? It's x. Good. So basically, set it up, outer equals 2 times the inner. Well, do we know what the outer value is yet? Well, do we know what the outer value is yet? It's x. So it's just 2 times, what's the inner value? Right up here. So then, can we multiply 2 times 9? You can't multiply 2 times 9?
18.
Yeah. That's all. This guy is 18. That's really all you're doing here. That's all that's happening. You're either dividing by 2, if you're going from outer to inner, or you multiply. If you're going from the inner to the outer, you multiply by 2. That's it. That's all that's going on here. So far, any questions? So that's our magic number. All right. Ready to move on? Any questions? Now, next couple problems that we do. Again, we're going to be using this idea, outer 2 times the inner. But now it gets a little more tricky because we're actually going to be solving for variables. But it's not as bad as it looks, don't worry. All right, let's make this even bigger. Let's see. I'll make this even bigger. That might have been too big. Okay, so we're on the back side. I think that might be too big, right? Is that too big? Okay. Okay, so number 5. Sorry, I thought I was about to sneeze. Sorry about that. Okay. Find the value of x. Again, take this idea of 2 times inner is the outer. So then, all right, so let's designate our sides. What's our inner side? 7x, yup. So inner is 7x. Then what's the outer? 17 what?
19.
That's your outer. Do we have enough information to solve for the x? We do. Because here's what we do. That's why it's key to identify. Key is identifying. So we take our 2. We're going to multiply by, well, what's our inner value or inner expression? Which one are we taking? We just wrote it on the paper. Which one is it? The 7x or the 17x minus 18? We just wrote it down. What's our inner expression? The 7x. So you're going to write it as, replace the inner part. When we see inner, replace it with the 7x. Then what's the outer expression? What expression are we using for the outer expression? There you go. Okay, well, what do we have to do with the 2 and the 7x? What's our first step? Multiply. So what's 2 times 7?
14.
And then, don't forget the x. So you have 14x equals 17x minus 18. Can we solve for x at this point? Yeah, we can. We can solve for the x. Because, well, can we combine the 17x and the 18? Can we do that? No. Now, on the other side of the equal sign is a 14x. So, which term are we moving? We're going to move the negative 18 or the positive 17x? We have to move the positive 17x. And that means, what do we do to both sides of our equal sign? What's that? Not yet. No dividing yet. Subtract. Minus 17x. Minus 17x. And then we do our combined like terms. These guys go away. Well, what's 14 minus 17? You're going to have a negative 3. Negative 3 what? And that equals negative 18. Now, can we solve for x at this point? What's our... Now we... What you said earlier, Dennis. What's that? Opposite. Good save. Yes, sir. Now we're going to do our division. Of course, the negative 3's cancel. You're left with x equals what number? Yeah, that's it. That's all. Now, I could have said, find each value, find each length. But we can do that. Do we have to for now? No. But you can do it. All you do is just replace. You can try it at home. Check. 7 times 6. And then 17 times 6 minus 18. You have to see whether or not if this final value is half the other final value. You don't have to do that. You don't have to do it unless if I tell you otherwise. All we want is to solve for the x, right? Follow the directions. Okay? Questions on this problem? Anybody any questions on problem number 5 here? All right. Now, number 6. Same idea. First, identify. Which one is the inner, which one's the outer? Which one is our inner expression? That's our inner expression. The 19x minus 36 is our outer. then we go back to what we need to do. So 2 times the inner is the outer. Perfect. There's your notes. No, thank you. Okay. So what we have going on here, again, 2. Now you definitely need your parentheses because you have to take the whole expression, 6x plus 31. Equals our outer expression, 19x minus 36. So now, there's our setup. This is the most important part of our whole problem right here. So now what we do, well, anytime we have a parentheses with a number to the left of it or right of it, what do we have to do with this 2? Anybody remember which property we need?
Multiply.
Multiply by distributing, yes. Distribute by multiplying, yeah. So that's the most important part for this type of problem. So it's going to be 2 times 6x. So plus 2 times the 31. Now, what do we get when we multiply 2 times 6x?
12x.
12x. And then what's 2 times 31? Okay, so 12x plus 62 equals, right now, just bring down that 19x minus 36. Now from here, now we're going to have to do some moving around. So the 12x plus 62 equals 19x minus 36. Now, the good news, the first step is a free step. Because we can't combine the 12x and the 62, right? We can't combine those 2 terms? No. Can we combine the 19x and the minus 36? No. Somebody has to move. Well, who could what would be the first step? Oh, no, don't.
Subtract 19 both sides.
What's that?
Subtract 19 on both sides.
Okay, you could do that. So no dividing yet, because we have to get, one time we're going to get that is when we have all our x's on one side. Remember, if need be, box. So Eric, you said minus 19x on both sides? We could do that. I'm okay with that move. I'm going to try to put this up a little further. Sorry, it's going to be bunched a little. I'm just doing this so we have a little more room when we solve this problem. All right, so yeah, you can do 19 minus 19x on both sides because what's 12x minus 19x? What's 12 minus 19? You have calculators, you can check it out. Negative 7x. Bring down a plus 62 for now. And again, notice, just want to make sure, line up your variable terms. Line them up. Not all of us have been doing that, and that's led to mistakes. So that is a key step Line up those variable terms. If you don't line them up, that's going to lead to mistakes. Get negative 7x plus 62, you still have negative sign with that 36, so it's minus 36. Now, what would be our next step? What's the next step we have to take? You have to subtract 62 on both sides. Joey is right, because can't combine these two terms. There's no x there. Negative 36 is by itself. And since there's no x here, because here, you leave this one alone. The goal is to get this negative 7x, or the 7x by itself. So yeah, by process of elimination, you have to subtract. So it's negative 36 minus 62. Now, be careful with your signs. Since they're both negatives, it's basically you're going to the store. You're buying something for $36. You're going to buy something else for $62. So you're going to be paying overall. How much are you going to be paying overall? 98. You have negative 7x equals negative 98. Basically, it's you owe some money, now you owe more money. That's the overall total you owe. Now you're down to one final step. What's our last step in this problem? By what number? Positive or negative 7?
Negative.
Gotta include that negative, yeah. Divide by negative 7, divide by negative 7. And then what would be our grand? Yeah, well, 14 would be our grand. So 14. Okay, questions? How are we doing so far? So basically, for the first couple problems, if you're dealing with the sides, so the first two problems that we dealt with were the sides. This is the formula. So this is to find your sides. That's with them, and remember, the inner is your mid-segment. Because the next two problems that we're going to be doing, if you notice the bottom two, are we going to be finding sides, or are we going to be finding angles? Look at the next two problems that you see. You're going to be dealing with angles. Now you're probably wondering, what do we do here? You're probably like, what do we do now? Well, turns out you kind of already know what to do. And I'll tell you why you know what you're doing. Okay, any final questions on number 6? Any questions on the number 6? How we got those values? Because remember, your homework is going to be very similar to this. It's going to help you prep for your quiz next week, which is going to be the last quiz of the quarter. All right. Now, you're probably saying to yourself, why are we going from sides to angles? But actually, this is easier than you think. Here's why. Now, you still have your inner and outer, However, what did we know about the relationship between the inner and outer segments of the triangle mid-segment theory? There was a relationship between the two. Okay? We talked about it briefly yesterday and briefly at the start of today's period. If you want to look at the front of your packet, besides the fact that the inner segment is half the outer, is something else. There's another relationship going on between these two lines, the inner edge and the outer edge. Give you a hint, it begins with a P. They're blank type of lines.
Parallel.
Parallel. And you know what that means, right? If these lines are parallel, kind of goes back to what we were talking about all of Unit 2. So basically, let's say these lines went on forever and ever. And this line went on forever and ever. Can we figure out the relationship of those two angles? Let's say if we zero in, I'll make it a little easier. How about this? Let's just take this part right here. So let's pretend this edge didn't exist. And you just had these two lines. They're parallel. And then we're talking about this angle and this angle. What can we say about these two angles in relationship to where they're located in the intersection? Anybody remember? That was all of Unit 2. That was part of your test. What type of angles? Let's say we talk about these two specific spots, these two specific angles. Anybody remember what was the relationship? Give you a hint, it begins with a C. Corresponding angles, that's right. In the end, these two angles are corresponding. So if we have corresponding angles, yeah, these are corresponding angles. What do we know about the relationship of corresponding angles? We just did this. And if you still need to take that Unit 2 test, you better know it. Otherwise, it's not going to be just a long quarter, it's going to be a long year. What's that relationship between these two angles? If they're corresponding, that means they're the same. Whoever said it was right. These two angles are equal measures. They're the same. So that's what we have going on here. Corresponding angles are the same because remember, your mid-segment and your outer edge, they're parallel lines. So since you have that taking place, you set those equal to each other. 7x plus 4 angle equals the 10x minus 11. Now at this point, can we solve for the x? We have enough knowledge or information to solve for x. Yes and no? We can. All right, I want you all to try that real quick. Give you all about 2 minutes. Try that problem. Hurry up and remember, when you're walking, cover the nose. Take a dive. Thank you. Okay. Marcus. Solve that problem. Just seeing what you did. You don't have to multiply by 2 here. No multiplying by 2. All you do, there's... And I'm gonna give you a heads up. You're gonna have quite a few problems that look like this on your homework and your quiz. And we've been working on these problems in the past too, so there should be no excuse. Zero excuse for solving these problems. Anybody get an answer yet? I'll look around, see how we're doing. Okay. We got a perfect result. Okay. With negative and negative. So you owe 11, now you owe another 4. How much would you owe altogether? We already started with a negative.
How do you put negative in?
Yeah, that's the symbol. She's in the building.
I know she did it 2 persons, that's why.
Alright, I'm not sure what she is at the moment.
I'll just have her reading all that.
Okay. Good. About half of us have it. That problem just got a whole lot easier for you, right? Yeah. Okay. We've got another 30 seconds. Okay, you have one little step. You're almost there, but that's much better now. All right. Since we have corresponding angles, set the expressions equal to each other. What did we get for a result? What did we get? Who can tell us?
I got x equals -5.
Close. Okay, so in the end, it's going to be +5 because what happened was when you divide two negatives, final result's going to be positive. Yeah, I think what happened was we forgot the negative there. So in the end, this one's going to be +5 because well, one way you could have done it, I know some of us did it this way, where we did the -10x first, which, okay, you could have done it that way, that's fine. And then, right here was where some of us were starting to make a mistake. You owe $11, now you owe another $4. So in the end, we owed 15. Now, you could have done the opposite way. Some of us did the -7x, and then +11. You would have had 15 equals 3x, but in the end, no matter how you did it, you should, regardless, get x equals 5. Remember, those negatives go away. All right, questions on that problem? Anybody questions on solving this problem? So again, there was more than one way you could have done this. But as long as you got x equals 5, your steps are good, I'm okay. Now, this other problem that we're going to talk about. And the value of x here. Now, problem's slightly different, but not a whole lot. Okay, this one's different, but it's not, we haven't seen before. We have seen this before. Pass this back to Adrian, please. Okay. All right, so backside, and then whatever you missed, get at it from Schoology or one of your classmates. All right, here. I'll make this a little. I'm going to write it so we can see it a little better. It might be okay on your paper, right? 5x plus 2. So again, we have an angle, 5x plus 2, 11x minus 30. Now, unlike before, the only slight difference, it's not really much of a difference. Yeah, we still have parallel lines. So when we had a problem, these lines are parallel. We're talking about these two angles here. Who remembers the relationship between these two angles? Oh, not quite. A little different. Consecutive interior. That's what we have here. Consecutive interior angles. That's what's going on in this case. Now, when we have consecutive interior angles, what's the relationship then between these two angles? So they're not going to equal, but there's something else. What do we know about the sum of those two angles? The sum of the two angles must add up to how many degrees? Cool. 180. And especially if you still need to do that test. That's another relationship you have to know. Consecutive interiors add up to 180. And that's going to be something we're dealing with all year. So these two angles, 5x plus 2 plus the 11x minus 30 adds up to 180. I know we've seen this before, ladies and gentlemen. We just saw this maybe a week or so ago. That's why we had the reviews. That's why we had a double review on this before our test. Now, look where our x terms are. Same side, right? Same side of equal sign. Well, can we combine them? Okay, so we have 5x and 11x. How many x's do we have altogether? 16x. Plus 2 minus 30. Okay, they're on the same side. Just combine. We have calculators, so we figure out what's 2 minus 30. Minus 28. Always right. All right. At this point, can we solve for x on our own? All right, try that real quick. I'll give you about 2 minutes. Yeah. And Cindy comes back. All right. Anybody find the next value yet? 13? Really? Agree or disagree with the 13? Anybody else agree or disagree with 13? Yep, that looks like a winner here. 16x. 208. We'll divide by 16. Will be 13. Very good. All right, questions on that problem? All right, there you go. All right, questions on that problem? Again, this is going down memory lane. All right. Now, the new stuff that we're going to talk about today, it's just a few rules. And I'll give you a hint. Think about a mirror. Whenever you look in a mirror, who do you see?
Yourself.
Yourself, your reflection. So when we talk about these perpendicular and angle bisectors, basically, think about the bisector as a mirror. You see yourself. So basically, whatever you see, you see basically yourself. That's what we have going on here. All right. Okay, so we're going to go to the next page. Get ready. And again, if you whatever you miss, get from a neighbor. Now, I'm only going to be very so for these 5 definitions that we see, I would only worry more about the top 3. So I would only worry about this one, this one, this one. We'll kind of see these later, but these are the 3 I worry about more for now. But those, it's not, you're never going to see them. You're going to see them. Like this median, you won't deal with too much, but you're going to kind of see it at times. And then the altitude is more like the height of your triangle, because has anybody been like out west, like maybe I don't know, Colorado, Nevada, any of those states out there? All right, because sometimes they'll say altitude of a certain city, like Denver, they say is a mile-high city, right? Because the altitude, they're a mile up in the air. So that's the idea of the altitude. Think about it like the height. Now, this is just going to be more technical stuff than anything. Basically, with a perpendicular bisector theorem, and they also say converse, basically what's going to happen is your perpendicular bisector is going to act like a mirror. So that's all you're really dealing with here. So everything that's on the left side of the quote mirror, all your measurements, you're going to be same as everything on the right side of the mirror. So all they're telling us then is with a perpendicular bisector, you have a line that goes right down the center part of your triangle. And it cuts this triangle exactly into two smaller triangles. Not only are these sides going to be congruent, these sides are also going to be congruent. So basically they're going to be saying AC is congruent to CB. I almost wrote the wrong letter. And basically vice versa. So that's all they're telling us. So I don't want to make it too. And the other part is when if it's perpendicular, you have a right angle. That's the other important part of this problem. So basically that's what you're doing. So all you're doing is just copying what you see here. So basically you're just copying this blank here, and these two down there. That's all you're doing. But to make it very simple, just think about it like a mirror reflection. You see, basically, whatever you see on one side of the mirror, it's going to be the exact same as what you see on the other side of the mirror. Okay? That's just basically, that's the quickest way to describe what we have going on here. Okay, questions before we continue? So basically, each side of the mirror is going to be exactly the same. All right. Again. Hold on.
I hear.
All right. What I'm going to say. Here we go.
Mister, can we stick going to this Friday?
Yeah, there's no after school Friday. All right. Really quick, I want to just mention something briefly. All right. Basically, the idea, again, is going back to the mirror. Going back to the mirror. So for this problem one, there's your bisector. Right down the middle. What do we know about the relationship of these two sides? That's your bisector going right down the middle. Think about a mirror. What can we say the relationship of these two sides will be? Just said it. When you look in the mirror, who do you see? Your exact self. So this side and this side, they're mirror reflections of each other. So if they're a mirror reflection of each other, what do we know about their relationship then? What's it? Say it again. They're the same. That's it. It is that simple. These guys are the same. Boom. 7x plus 24 is the same as 13x minus 48. Now, can we solve for an equation like this?
Yes.
Yeah, we've done it before. Here's your 7x. Here's your 13x. Here we go. What would be our first step here? Who can tell us?
13 goes back.
Okay, you could do that. Okay, you're saying 13, you're saying 7. All right, let's figure it out. Okay, why are you picking 7? Okay? Now you picked why'd you pick 13?
Oh no, you picked it.
Okay, you both were right in the end. Now, out of the two, Adrian, I like your idea a little bit better. Your idea was not incorrect. Don't get me wrong, Eric, because you could have done that as well. Minus 13x both sides. So either one step was correct. Only reason why we're going to go with Adrian's because she has the smaller number. You want to move the smaller number. So the 7x's go away. 24 equals, what's 13 minus 7? And then don't forget we have to include the x. So we have 24 equals 6x minus 48. What's our next step here?
Change the 48 to,
So what do we have to do with the 48?
add 48 to 24.
Add the 48, both sides, yes. So then what's 24 plus 48?
72.
72.
Okay, so we have 72 equals 6x. What's our last step here? Okay, do it. You're done.
What fingers we got today?
56.
Thank you. That was my fault. I totally forgot to write it. So 72 divided by 6 gives us what answer?
12.
X is 12. I'll just put that last step over here.
I said, can I come for 6 period?
I'm not available because I have a meeting during 6th period. Yeah, I totally forgot about it, so that's my fault. I know I originally said I was available. Now, next Tuesday, I will be around for 7th period. Yeah, 6th period today I cannot do. I have a mandatory meeting I have to attend today, so I do apologize. All right, questions on this problem here? Now, number 2 is the exact same idea. I want you all to try number 2 on your own. So number 2, same idea. A mirror. 2 opposite sides are equal to each other. I want you all to try number 2 on your own.
Okay.
Probably 15 minutes. Look, I'm going to talk briefly about these two. collectively. So that would work out.
Beautiful.
So I'm gonna put that. So that's our goal. Gonna be tight, but I think we got it. Okay. Number 2. Did anybody solve for X? Or we're still working on it?
How about X equals 2?
You got X equals 2? 2? All right, that looks correct. Yep, that's going to be correct because subtract 9x first. No. X is 2, very good. Good job. Okay, questions? Again, here's your mirror. Okay, well, it's showing the mirror. Questions on this problem? Remember, they're equal. All right. Now, last 2 problems are going to be just about the same idea. I mean, I'll technically talk about that little blurb in the middle. I really don't want to spend much time on it. So basically what's happening with the angle bisector is the same idea. So when you're bisecting the angle, they're basically saying that these sides right here, BD, DC, are going to be the same. VC, congruent. And it's basically just going back to the mirror idea. There's your mirror right here. And then they're also just flipping it as well. And they're just saying, again, when you have your mirror, I think all they're doing now, they're just saying that what's going to happen is this angle right here, this BAD, is congruent to CAD, that angle right there. And then on a technicality, you could also say this angle right here, and this angle right there are also going to be congruent. Because in the end, with your triangle, what must the sum of your 3 angles in a triangle add up to be? How much? 180. So these angles are going to be congruent, those angles are congruent, those angles have to be congruent. That's basically all that's taking place. So again, you just have your angle AD, C, ADB. That's basically all they're saying. You have an angle bisector, sides are congruent, angles are congruent. That's really all. So basically, these last 2, in both cases, what can we say about these two sides? They're both what? Here's your mirror. They're the same. They're the same. And then what about these two angles? The 5x minus 11 and the 8x minus 41. They are the... There's your mirror. What can we say about those two angles? They are the same. So in both cases, all you're doing is set 4x plus 30 equals 9x minus 5. And then 5x minus 11 equals 8x minus 41. So what we're going to do, you all are going to work on these two problems for the next few minutes. We're going to pass back some old work and a new homework assignment. Basically, the new homework assignment is going to be basically everything that we've done the last two classes. Yep. Oh, yeah. Let's see these. Okay, these are not finished. These are not finished. These were finished. This. And then before we leave for the end of the period, we're gonna pass back some assignments, and we're gonna also pass out some homeworks. We'll work on those last two problems for a couple minutes.
Who's homework?
Yes.
Yes, so Ms. Ahmed is passing out the new homework assignment. It's not as bad as it looks because the diagrams make it longer than it really is. So your home,
This was homework?
no, that's an old
I
assignment.
know, but this was homework, right?
No, that was a quiz. That was an old quiz. I've been wanting to give them back, but everybody's either been absent or not completed.
I got it. No, it makes me feel better. Thank you.
Okay, let's not talk about that right now. Let's finish those last two problems, please. There's more, you know, the more thorough.
We stay on film.
Yeah, this one right there.
That's not good.
Oops, sorry.
Hey, do you have any extra?
Right now they're on school again.
So,
You can put them up at home. I really don't have hard to
That's
get
the
more.
one stay on film.
I mean, check. You might have them. You might have more than you think.
no,
Thank you. Thank you.
Bruh.
Yeah, let's see.
I mean, at
But
least.
I-
Like you got something on board.
Oh, jeez.
I can think it's funny. Yeah.
Yep.
Oh. Maybe I can.
Oh, optional add-on activity.
You never know, but I think
Yeah.
it's. Oh, wait.
Okay,
Mr.
Yeah.
The item for number one, it wasn't like, showing up.
did you click on the actual title?
Yeah.
Let me look, all right, because there's more, I'm gonna talk about that in a minute. Okay, really quick, what's going on here? Did anybody get a value for number 3?
I got 7.
Okay, that's correct. So for number 3, your X is 7.
One,
You can check it.
you know, like a C or C.
Anybody get number 4? You're right, it is 10. Very good, Andrew. All right, here's what we have going on. So, Andrew, thank you for number 4. Adrian, thank you for number 3. You both were correct. You can check them. All right, going forward, here's what we have. You have a homework assignment. It's not as long as it looks. Because a lot of it is the diagrams. The diagrams make it a whole lot longer than it actually is.
Yes.
Right behind Dennis, you have a whole bunch of. So, really quick on the homework. Part A and B, this was from the first day. Basically, add up your smaller numbers. Check, is it bigger than the larger? Part B, what you do, this is where it's at less than X, less than whatever. You either subtract the numbers, then you add your numbers. So that's what we have going on for the first parts. Part C.
Oh, this is easy. We were doing this last time.
Yep. Part C, again, this was from last time. Set up. So you have your side. So for both of them. Set up the length. Side. And then whatever the last letter was your angle. So for instance, your shortest side is 8. What 2 letters make up the number 8? What 2 letters make up that side? What 2 letters? Q and R. What letter's missing from that triangle? What letter did I not write down from that triangle? There you go. That's this type of problem here. So, least to greatest, do the same thing here. Write the letters of the 2. Write the 2 letters that make up the side. Whatever letters you didn't write, that's your last side. Part D is similar. But remember, for part D, you're going to have to do a little work. You're going to add these 2 angles, and then subtract whatever is 180 minus whatever the sum of those 2 angles are. Same thing here. 180 minus whatever. All right, and then, yeah, I think I'm running out of time. But that's all last time. And then this is from today. 2 inner is outer. That's 9, 10, 11, and 12. Remember, same. These 2 add up to 180. We did these types of problems. And then the last 4, all 4 cases, you set them equal and solve for your X. 1, 2, Let them equal, self-corrects, and then you're done. Now, if you go to, really quick, if you go to Schoology for the add-on activities, you have to click on the actual title. You have to actually click on the actual title of the add-on activity. Now, I did also post a PDF version, so you can print that up as well. All right. Have a good weekend. And again, you can print up missing assignments from Schoology. And then, you said it didn't work on Schoology, Brian?
Yeah.
Like, did you use your phone?
No, my computer.
That's weird.
So when I clicked on the two that you told me, first one, it showed that it wasn't available.
Ooh.
And then second one, Miss Pierce, she printed out for me.
Okay.
So I'm gonna turn in the work thing.
This one.
Yeah, all right, that's fine. So we'll look at it, and then worst case scenario, whichever you're missing. Let me see, 5. All right, I don't have 6. Okay, 6 amount. Let me see if I. What do you have 6 period?
I have James.
Miss Sagan?
Yeah.
All right, I might have an idea. For what to do. Okay, thank you for letting me know. I might have an idea. All right, thanks a lot.
All right.
You too, thank you, Mr. Ed.